So this problem is similar to the multi-period inventory model that we've seen when we learn about linear programming formulation. Now the difference is there is a cost that is called production smoothing cost. So this cost occurs when your production level or production amount changes from one period to the next. So let's say at this period you produce this much amount of products, and then if you increase it in the next period, there is a cost of the increase. If this is your amount at this period, if you decrease the production level at the next period, there is also a cost for that. Because when you increase the production level, maybe you need more money to train new people, you need to hire new people, you need to buy a new machine or a new setup or so on. So whenever you change the production amount, there is a cost, and that cost is production smoothing cost. It is called production smoothing because when you have this cost embedded into your model, the solution or the decision maker will try to create the production level that is as smooth as possible. It means that if possible, the production amount from one period to the next period is the same. So there is no change from one period to the next. Let's see the example. So in this case, Mondo motorcycles need to determine its production schedule. So you know that the decision variable should be about the production schedule, which means that how much they produce at quarter one, how much they produce at quarter two, and so on. There's the information about the demand for each quarter, and then let's take a look at the cost. The first cost is $400 to manufacture or to produce each motorcycle. The second cost is that if at the end of a quarter you still have motorcycles left that are not sold yet, means that you need to pay $100 per motorcycle. The third one and the fourth one later is the production smoothing cost. If your production amount or production level increase from one quarter to the next, it means that you need to pay $700 as many as the number that you increase your production, because you need to train more employees, so you need to pay $700 per motorcycle that is produced more than the last quarter. If you produce less than the previous quarter, you also need to pay the cost. So that's the fourth one, because you need to lay off some workers. There is decreasing in morale in your workers and so on. So you need to pay $600 per motorcycle. So if you decrease as many as let's say 5 motorcycles from the previous quarters, you need to pay 5 times $600. Okay, so then you see it says all demands must be met on time. So these are the constraints, that the demand for each period must be met on time. And then this problem wants us to minimize the total cost during the next 4 quarters. And then also it has the information that at the beginning of quarter one, we do not have any motorcycles in the inventory. And then the quarter before quarter one, we know that we produce 50 motorcycles. We need this information because we would like to compute the difference between the amount that we produce in quarter one and the previous quarter, which we can say like quarter zero. So that's the information in this problem. I will give you a pause on the video to give you the time to read this problem carefully and collect all the required information. Now let's formulate the problem. For me, sometimes it's easier to start with the objective function. Here, the objective of the problem is to minimize the cost. So let's look at all the things that contribute to the cost. So first, we need to know how many motorcycles we produce each quarter because it has a cost of $400. We also need to know the ending inventory of each quarter, right? Because for each motorcycle that we have for the ending inventory, we need to pay $100. We also need to know how much we increase uh, our production level in this quarter compared to the previous quarter, which we also need to know if we decrease the production level. So here we may increase or we may decrease the production level. Now you can see that's why we may need a URS variable. So the total cost comes from production cost 400 times the amount of production at each quarter. So let's name them P. And then inventory cost comes from the ending inventory of each quarter. Let's name them I. And then we have the smoothing cost due to increasing production and due to decreasing production. Okay, so PI, let's talk about P and I first. So PT is the number of motorcycles produced during quarter T, and I is inventory at the end of quarter T. And then because you may increase or decrease the production level, you may say that the variable is XT, the amount by which quarter T production exceeds quarter T minus 1 production. It means that if the amount of XT is positive, it means that you increase your production. If the amount of xt, or the value, I will say, if the value of xt is negative, it means that the amount that you produce this quarter is less than the previous one. But as you've seen in the previous video, we cannot have one variable as URS like this. Then we can't have this because it means that we need to change the procedure in our simplex algorithm. What we need to do instead is to define two variables, xt prime and xt minus prime, such that xt defines the increase in quarter T production compared to quarter T minus 1, and then xt double prime define the decrease in quarter T production compared to previous one. By using these two variables, we may describe this xt variable using two non-negative variables. Now let's talk about the constraints. The first constraint is that you need to define the balance in the inventory. It means that you need to define what is the relationship between the ending inventory of the previous quarter to the ending inventory of this quarter. As you've seen before in the multi-period inventory problem, this is how to do it. The ending inventory of this quarter equals to the ending inventory of the previous quarter plus how many you produce this quarter minus how many you sell this quarter to fulfill the demand. So you will have 4 constraints here for each of the quarter, and then you know that at the beginning of time 1 you have 0 inventory, or you can say the ending inventory of time 0 is 0. So that's how you get this 0 here. The second constraint is to define the difference between the production in this quarter and the production of the previous quarter. So remember that we define the difference with xt. So xt is the difference between the production in this quarter minus the production of the previous quarter. We define it as xt. But because difference can be positive and negative, remember that we will replace this kind of URS variable with 2 other variables using this relation, xt prime minus xt double prime. So for each of the period, you write down the equation that shows the difference between period t minus the production in period t minus 1. And then this value 50 here, because in the problem they say that the production level on quarter 0 is 50. So this is the complete formulation for the problem. Do not forget to write down the sign restrictions. All variables is greater than or equal to 0. Notice that we do not have any URS variable anymore because we have replaced xt variable with xt prime and xt double prime. And these variables xt prime, xt double prime, they are both greater than or equals to 0. And then if you solve this problem, probably you will need big M or two-phase simplex method because all the constraints are in the equality sign. You will obtain this optimal solution with the ending inventory at period 4 equals 30. If we look at this optimal solution, we can notice that it is better for this problem to have 30 units at the ending inventory compared to decreasing the production amount. So you see that the production amount at period 4 is still 50. It does not decrease from period 3. Although you will have ending inventory, you are producing too many motorcycles. In this example, this solution is better because you see that the amount of, if you decrease the amount of production, you need to pay $600. While if you have ending inventory, you just need to pay $100 for each unit of motorcycles that you have left. So you see that the effect of the production smoothing cost is that now the solution tries to make the production level from one period to the next period as smooth as possible. So it tries to have the equal amount of production from one quarter to the next one. Now here's the question. We have seen the optimal solution of this problem in the previous slide. And then if we look at this constraint, P3 minus P2, so that constraint equals x3 prime minus x3 double prime. If we plug in if we plug in P3 equals 50 and then P2 equals 55, so P3 minus P2 equals minus 5, right? Because 50 minus 55, the result is minus 5. So minus 5 equals x3 prime minus x3 double prime. Seeing the last equation, we know that x3 prime must be 0 and x3 double prime equals 5. Is this statement true or false? The answer is true. We know that when we have two variables to represent a URS variable, and then if this value equals minus 5, it must be that the first one, x3 prime, is 0, and then the second one, x3 double prime, must be 5. Because remember in the previous video, you see that if one becomes a basic variable, in this case x3 becomes basic variable with a positive value, the other one must be 0. The other way to see this is that you see that x3 prime has a cost if it has a positive value. And then x3 double prime also has a cost. So when you want to minimize the total cost, of course you will try to make any of them, actually you will try to make both of them equal 0. But if you cannot do that, then you will try to make only one of them equals 0. So in this case, if you want to reach the number minus 5, the best thing is to set this equals 5 and then set this equals 0 for x3 prime. So that's all for this week, and also that's all you need to learn for this semester. So in the second topic, you've learned from the very beginning how you may solve a linear programming problem using simplex algorithm. And then we also learn about big M method, two-phase simplex method. And finally, we're talking about variables that can be URS. So see you after the midterm and good luck for the exam. Thank you.